In .NET MAUI, behaviors let you add additional functionality to controls without subclassing them. This keeps your UI code clean and encourages reuse. For example, you can create a custom behavior to validate text length in an entry control. Behaviors can listen to events, change UI properties, and enforce rules, making them powerful tools for UI logic that doesn't belong in code behind or view models. In .NET MAUI, custom renders are used to customize the platform-specific implementation of a control. This is especially useful when you want to tweak or extend the functionality of a default UI control for different platforms. To implement a custom renderer, define a shared control in your core project, such as a custom label. Create a platform-specific renderer in each platform's project to override the default behavior. For example, on iOS, you can create a renderer to change the text color of your custom label. While .NET MAUI uses native controls under the hood, custom renders allow you to take full control of platform-specific features. In .NET MAUI, you often need to write platform-specific code to access platform-specific APIs or behaviors. There are a couple of ways to handle this. First, you can use compiler directives to execute code conditionally based on the platform. Second, you can use dependency injection and dependency service to register platform-specific services and access them in shared code. This allows you to write clean platform-independent code while still supporting platform-specific functionality when needed. In .NET MAUI, you have several ways to handle navigation depending on your app structure. Stack-based navigation is the traditional way, where you use methods like push async and pop async to navigate forward and backward in a navigation stack. Shell-based navigation leverages URIs to navigate between pages. This is more declarative and works well with shell. Modal navigation allows you to open pages on top of the current stack. Each navigation strategy has its use cases, and you can choose the one that fits your app's flow. In .NET MAUI, data binding is a powerful feature that connects your UI with your view model or model. This allows your application to reflect data changes automatically without needing to update the UI manually. You set the binding context of a page or control to the view model. Then use binding syntax in XML to bind properties to UI elements. One way binding sends data from the view model to the view is, as an example, two-way binding allows data to flow both ways, which is commonly used for editable fields. Additionally, command binding allows UI elements like buttons to trigger actions in view model using I command. In .NET MAUI, dependency services are used to provide access to platform-specific functionality. You define an interface in your shared project and implement it on each platform. First, create the interface, then implement it on each platform. For example, as shown in the example. Dependency services are a powerful way to handle platform-specific logic while keeping the shared code clean and reusable. In .NET MAUI, shell is a higher level container that helps simplify your app's navigation and layout. It provides a consistent and structured way to implement common UI patterns like tabs, flyouts, and deep links. With the shell, you can define your entire app navigation in one place using XAML. It supports URI based navigation, which makes it easier to navigate to pages with parameters. Shell also gives you built-in features like a flyout menu, back navigation, and route mapping. This helps reduce boilerplate code and keeps your navigation logic clean and maintainable. In .NET MAUI, a view model acts as a bridge between the UI view and your data or business logic model. This is part of the MVVM architecture, which stands for Model View View Model. The model contains the application's data and logic. The view is your XAML page defining the UI. The view model provides the data and commands that the view binds to. Your view model should implement iNotify property changed to allow automatic UI updates when property values change. It also contains iCommand properties to handle user actions like button clicks. This pattern ensures that your application is testable, scalable, and easy to maintain because it separates concerns cleanly between UI and logic. In .NET MAUI and MVVM architecture, commands are used to handle user interactions like button clicks without writing logic in the code behind. This helps maintain a clear separation of concerns. You define a command in your view model using the iCommand interface or more commonly the command class. The method onSubmit contains the logic to execute when the button is clicked. In XAML, you bind your button to this command. As an example, commands help keep your UI logic clean and ensure everything is testable, reusable, and easily maintained. In .NET Movies MVVM model, I notify property changed is a vital interface. It allows your view model to notify the UI when a property changes so the UI can update automatically. The interface can contain one event. As an example, whenever a property like name changes in the view model, you call the onPropertyChanged method to raise the event. This signals the UI to refresh that value. This makes your app dynamic and responsive, as users will instantly see updated values on the screen when the underlying data changes. In .NET Movie, navigation can be done in two main ways, using shell navigation or navigation page. Shell navigation is preferred for apps using a structured layout. Example, await shell.current.go to async of name of details page. Make sure to register the root like routing.register root of name of details page, type of details page. Alternatively, more manual control use navigation page like await navigation.push async of new details page. Both methods support navigation stacks and parameter passing, but a shell offers more built-in support for tabs, flyouts, and deep linking. In .NET Movie, you can pass data between pages using either the constructor approach or query parameters, depending on whether you are using navigation page or shell. With the navigation page, you pass data directly via the constructor. Await navigation.push async of new details page of selected item. In the target page, accept the parameter and bind it to the context. With the shell, use URI based navigation and query parameters as in the example. Then, in the destination page or view model, use query property to bind the parameter. This keeps the app structure clean and support deep linking in shell-based navigation. In Xamarin.Forms, we used renders to bridge controls with the platform-specific implementations. In .NET Movie, this is replaced by handlers. Handlers are more efficient and rely on composition, which makes them easier to customize and maintain. For example, changing the background color of an entry or on Android can be done with just a simple handler mapper. With handlers, .NET Movie delivers better performance and developers gain more control over UI behavior in a cross-platform way. In .NET Movie, add singleton and add transient define How long a registered service should live. Add singleton creates a single instance of the service that is shared throughout the app's lifetime. This is useful for services that manage shared data or state, like configuration or caching. Add transient creates a new instance every time the service is requested. Use this for lightweight, stateless services like data validators or temporary logic processors. Choosing the right lifetime depends on whether you want a shared instance or a fresh one each time. For most view models, transient is a good choice, while for app-wide services, singleton is more efficient. In .NET MAUI, custom controls let you create reusable UI components by extending existing controls or combining them. To create a simple custom control, inherit from an existing control like label and customize it. As in the example, you can then use it in your XML by referencing the namespace. For more advanced custom UI, you can create composite controls using content view, which lets you design layouts in XML and add logic in the code behind. This approach promotes clean design and reusable UI patterns. .NET MAUI offers several types of pages to organize your app's navigation and layout. Content page is the most basic page type. It holds a single layout like stack layout or grid and displays one screen of content. Navigation page provides a stack-based navigation system. It lets you move forward and back between pages using push async and pop async. It is ideal for apps where users drill down into content. Tabbed page allows you to show multiple pages with tabs. Each tab represents a child page and users can switch between them easily. Use each page type depending on your app's layout and navigation needs. In .NET MAUI, the MVVM model view model pattern helps in separating business logic from the UI. The model contains data classes like product. The view model holds the data and logic. It implements iNotify property changed so that UI updates automatically when data changes. The view is the XML page that binds to the view model using data binding. For example, you can bind a collection view to a list of products and display each product's name. You set the binding context of the page to an instance of the view model, and that completes the MVVM structure, making the app more scalable and testable. To bind data in .NET MAUI, you connect the UI to the view model using data binding. Start by implementing iNotify property changed in your view model. This interface notifies the UI when a property value changes, keeping the view in sync. For example, if you have a username property, you raise on property changed whenever the value changes. In the XML view, bind to that property using the binding syntax, as in the example. Finally, set the binding context of the page to the view model. This connects the data source to the view, enabling two-way updates automatically. iNotify property changed is a critical interface in .NET MAUI's MVVM pattern. It allows your view model to notify the UI when a property's value changes. Without it, changes in data wouldn't reflect automatically in the UI. You implement the interface by declaring an event called property changed. Then, in each property setter, call on property changed when the value is updated. For example, if you change the title property, the UI will be instantly updates any control bound to it, like a label. This makes your app reactive and keeps logic separate from UI design. In .NET MAUI MVVM, commands allow you to bind UI interactions like button clicks to logic in your view model rather than writing code behind. You define an iCommand property in your view model and bind it to a method. In this example, greet command calls on greet, which shows a message. In XML, bind the button's command property to greet command. When the user taps the button, the logic in your view model executes. This keeps your UI and business logic separate and supports a clean MVVM design.